What?
How's work, buddy?
Work was work.
Next subject is going to be, if I can find it, here, I don't see it. Screen here. This is where you working at, Trail, scalping doors and hardware.
No, I'm not out there.
You're not at sheltering doors and hardware.
No, I'm with Mark.
Oh no, you Mark. I'm thinking about the Grace on Cold. Grace on Cold is over there. Mark just left here just a minute ago.
Oh, me, yeah, I'm with
How they doing over there? Keep busy? They got a request for more apprentices.
Okay, well, yeah, they keep me busy.
That's good. Well, keep your hours so you get your raises. You guys should be turning in your blue book. What's up, Mr. Springfield? My LA brother. All right. So what I want to do, gentlemen, can everybody see my screen? Right?
Yes.
All right. I had a class I was teaching the other day, which was dealing with form setting. And we were dealing with some vocabulary here. This is foundation design forms. And we got foundation design form construction. And so it's where it all starts. You know, when they talk about the significance of the carpenter is the most essential person in the trade. I mean, when we say the most essential, he is the essential person in the trade. Nobody can run wires. Nobody can put plumbing pipes. Nobody can put insulation in walls, set windows and doors, unless you have a carpenter that's going to build the structure. And he starts from the foundation to the turning of the door knob when the job is through. I'm giving the keys to the owners. That carpenter is a very important person. And so you should learn all the trades that are available to you. Even though you might be a specialist, you may be a structural concrete form setter, you want to be versatile. And this is what this apprenticeship program allows you to do, to learn the different trades. So here is some things that, some of this stuff, because I've been around 40 plus years in this trade, and there's always something new that you're going to learn because you haven't been in that particular industry. I can't really tell you how to set T-bars and put a laser up and drop a drop ceiling in, but I can cut stairs and I can do several other things. So I'm going to let my friend here read us. I'm going to try to do this here. And we're going to have some of you all that want to read. I want you to jump in here and read this, because when you read it, you're recording it. Your ears is closest to your mouth. And so you're going to remember this stuff. So when I quiz you, I think I got my quiz book over here. We do some pop quizzes. And we're going to get into that. All right. So we want to describe the use of inverted T-shaped foundation forms. This is what it's calling. This is the objective, is to describe the shape of T-shaped inverted forms. Then review the procedures for constructing footing forms. Number 3 is to describe the construction of wall forms. Number 4 is to describe the construction of monolithic inverted T-strap form. Monolithic means a solid pour by itself. And so that's really what you're looking at. So let me let my friend kind of, let me get this out of the way here. We got this. And where's my friend here? All right. Somebody's got their phone on. You got to mute it. You got a little background in the background. I think that's Isaac. I got some background in the background. Thank you. All righty. Let me see something here.
1. Describe the use of inverted T-shaped foundation forms. 2. Review the procedure for constructing the construction of wall forms. 4. Describe the construction of monolithic inverted T-shaped foundation forms. 5. Explain how the height of pour is established. 6. Describe the use of rectangular and battered forms. 7. Explain how pier forms are constructed. 8. Describe the construction of grade beam forms. 9. Review the construction of slab at grade forms.
What, anybody know what a grade beam is in foundations? Okay. I think we had that in lesson 1.
10. Define insulating concrete forms and describe their use in residential and light commercial construction. 11. List and describe common tools used when working with insulated concrete forms. 12. List the devices and methods used to attach finish materials to insulating concrete forms. Inverted T-shaped foundation forms. Inverted T-shaped foundations are used for full basements or crawl spaces. Spread footings of inverted T-shaped foundations provide good load bearing on all types of soil. The forming procedure used for inverted T-shaped foundations depends on the CLI made, soil condition, and height of the foundation walls. For low inverted T-shaped foundations, concrete for footings and walls is placed at the same time, or monolithically. For high inverted T-shaped foundations, concrete for footings and walls is placed separately. Figure 392. Footing forms may be required on one or both sides to contain concrete when the soil condition is unstable. 330. Footings. Where the soil condition is firm and stable, footing forms may not be needed. Instead, a trench is dug to the width and depth of the footing and concrete placed directly in the trench. See Figure 391. Where the soil condition is unstable, a footing form is built using 1 or 2 lumber. See Figure 392. With 2 lumber, stakes are placed farther apart and less bracing is required. A procedure for constructing footing forms is shown in Figure 393. Figure 391. Concrete for footings may be placed directly in the trench with.
Now, if you look at these footings right here, it's a little different from what you see on a foundation. Namely, when they talk about footings and foundations, a footing is basically, it has the base, which is the footing. And this footing is usually 12 inches wide by 12 inches deep. And then it has a little wall that comes up, which is like the stem wall. This is a footing, and the ground is here. It's under the ground at this point level right here. Now, what's required when you're building a house, you got to be a minimum of 8 inches above the grade from earth to wood contact. So from here to here, we have to have 8 inches. And then there's the joist that goes on top of it if this is a conventional floor. And then there's a wall that goes on top, which is the 2x4 stud wall that goes above it. And then you have a clearance, a minimum of 18 inches for the crawl space under the house. So this is all for moisture and termites. So this is what they call commonly they have called a footing. So that footing is a minimum of 12 inches by 12 inches deep. And that's, this is what the foundation of a house is on. So everything we build, we come out with the first thing you do when you lay out a footing, there's a formula to making sure the building is perfectly square. Anybody knows the right angle of a triangle? What is the hypotenuse? 3, 4, and 5. All right. So that gives you your 90-degree angle right here. This is 5 right here. This is 3 over here, or 4, and 5. So when you're laying that footing out, you also want to pull a diagonal tape to show that you got 100 feet this way and 100 feet this way. So you're perfectly square. So what is important about this is when you get ready to put your T-bars in the ceiling, your room is square, and you're not having to slice off the T-bar towel to try to make it fit because the wall is out of square or out of plumb. It's crooked. So when you get ready to put plywood, you're going to miss the plywood sheeting. So that foundation guy is very important because he lays everything out for me to follow when that house is done or when this building is being erected. So it doesn't make a difference if I'm coming in here with a building that has these kind of shapes on it and it goes up this way and comes back over here and comes back this way. So here is my ridge and my roof. This is a gable end roof, which would be coming here, California fill, which would be here. And this roof ridge comes this way. And so this is my ridge of the roof. This is the peak of the roof. So when I'm looking at this roof, I'm looking at it like this, and it's going out like this, or so forth. Everything has to start with one corner, 3, 4, and 5, or 6, 8, and 10, for pulling longer forms. So this is part of these, the most important part of it is understanding the foundations. So you want to figure out why your doors are fitting and your windows are fitting and your building is level. Well, that starts with that guy that sets up the concrete foundation. It's not the concrete guy, but it's the carpenter. And so in this instance, we're looking at these boards that are here. Let me see something here. Come on up here now. All right, these boards that are pointing down here in the ground, these are called floating forms. So what they're doing is they're running 2x6 here, and they're nailing them back across here. So that wood is kind of sticking out like this, and they're putting stakes in the ground back over here. And then they're hanging that form off of it this way. That's that 2x6. Then what they did was they came back in the inside. They got some kind of plywood or drywall that they're hanging down off of this. That's hanging down here in the footing. And so when they pour that concrete and the ground is going like this, that concrete with the steel in place, the rebar, you have a nice big slab that's going to go in the manner. These floating forms right here are the ones that are holding this 2x6 to do what they're doing here. Normally and they also got some stakes in the inside. So they'll run the, look like drywall or whatever they got in here, and they want it to be perfectly straight. So they got stakes in the inside that's kind of keeping it from kicking back out, because you might have, the ground is like this. And if you put that form in the inside, if it's not a form in the front of it, it might push out, or push in, so they have that. So this is one of their T-bar foundation form setting. So you want to learn a little bit about foundations. You want to understand what's important. Even if you are a contractor, if you become a general contractor and you might be a specialty trades guy to put in HVAC or put in suspended ceiling or flooring, you want to make sure that guy is laying out your slab right. So when you get ready to do your job, you ain't got, you don't have the the wood going out of the floor going off a square, and you got to start making special cuts you know, to accommodate everything. So read on down,
Firm
preacher.
and stable soil conditions exist. Foundation forms and forms for slab at grade foundations are constructed by carpenters. The foundation location is transferred from the building lines, which were established when the building site was laid out. Forms must be properly constructed and braced to ensure the forms do not move when concrete is placed in them.
So what we have, he talks about following the property line. So when a guy basically you buy a lot and your lot is 50 feet by 100 feet. Now the guy next door, he has a lot that's 50 feet by 100 feet. And this is the property line. Property line is here. So you have your property line. You want to make sure you don't put your house too close to his property line, because the setback says you got to be 4 feet apart. So he's got 4 feet and you got 4 feet. So between your house and his house is 8 feet. So if your house catch on fire, it's going to the likelihood of his house catching on fire will be slimmer, because you have a distance of 8 feet between the two of you. So when you're laying out this foundation, you got to make sure that you follow the layout from the guy that did the surveying of your lot. He puts these hubs down there, points. He gives you a little point in the ground and shows you this. And then so what you got to do is you got to pull a string straight through, and you got to stay back. And if the back of the property says that you can't be back no more than 30 feet away from the back yard, you got to keep 30 feet in the back. And in the front yard, you got 15 feet. So your house has to stay within the boundaries of 15 and 30 and 4. So this property line that the contractor or the foundation guy, which is namely the carpenter, is going to lay it out. They do have foundation carpenters and people that are basically, let me get out of here, get rid of these lines. You have guys that are basically laying out, and they go out and they lay out the forms. So whether it's a commercial business, building, or residential. All right, let's go to the next page here, gentlemen. Now I want you to study this diagram for a second, because this is really what it's all about. Remember I talked about staying off of the property line and following the building, where the building is going. They call these things batter boards. Right here, it's a batter board. It's construction concrete footing forms. Batter boards are something that stays in the ground permanently during the construction. So if you lose while you're forming it up, if you lose, if you get out of square, your strain goes down, it gets dropped, you just hook it on that nail that's pulling parallel to your property. So if you have a batter board and it's like this, you have a nail right here that's pulling 4 feet from that property line. And then you have another nail back here that's pulling 30 feet from the back of the property line. So what you're going to have is, when you start putting your square and your building up, 3, 4, and 6, you're 30 feet back and you're 4 feet on the side. That's where you're laying out your wall. You're laying your wall out, your building foundation. So when you get to digging and trenching, the digging ain't gonna be all straight, but you have that string that pulls straight through. And so when you put that form on there, you have a nice straight footing and foundation wall. So what they're showing here, they have the batter board going this way, and they have the string going this way off of this batter board. So this is a 4 feet distance. This one here is where they want the other one. So they actually came off of this piece right here. Then you have a plumb line, which he's showing here. Now that's a little different. And he's got some stakes underneath there, setback distance from where the footing goes. He's got a plumb line that's going straight up and down. That's almost if you're dealing with a basement or something. That's not necessarily a regular footing, because we have enough ground room over there. So they got the plumb bob number 1, drop the plumb bob down from the building line. Then they got here. Anybody recognize this concrete? What kind of pour is this on this concrete? Tell me what we got here. You see a joint right here? What do they call that joint? That's not a monolithic pour where it's concrete poured all at one time. It's a cold joint, and it's got a keyway in it. That keyway keeps that wall from sliding. Instead of having flat concrete poured on top of a flat concrete footing here like this, you have a keyway in here. So
yeah, those keyways need to be clean all the time.
yes, yeah, you got
You
it.
have to clean those keyway. That's my little conduit right there. That's concrete form. You doing footings, huh?
Yes,
Footing
sir.
forms, huh?
Yeah, we
Spring
do.
color here. Just checking in.
That's right, Ronnie. That's right. Well, you smarter than the average bear, brother. So here's the thing: you got your steel coming up through there, and that keeps that wall from shifting out. Because if you didn't have this, if you had it like this, and the dirt was pushing away, that concrete footing can move. So you want it to basically be locked in. So we got that, and yeah, let's see. So we have all this in shape. And what we got, let me get rid of these. So I'm gonna let him tell me a few things, and we're gonna jump in. Me and Ronnie gonna jump in and put him straight, because I know Ronnie knows.
And how deep do that keyway have to be?
Keyway is usually 1.5 inches by an inch and a half thick by 2 inches wide, and it's basically taking a 2x4. You take a 2x4 that's like this, and you kind of cut it at an angle, and you cut it like this, and you cut it as an angle, and you lay it in the concrete when it's wet, right? So it's laid in the concrete or either staked out in place so it holds that footing. And then you got steel in here that's coming up and just hanging through the top of it, but this keyway is here. So you have like holes where you got the steel coming through it. So when you pull this up, not only is the keyway gonna lock that concrete from falling, from moving, but that steel that's in there is kind of tying them together, right? So
Yeah, we're gonna give them a definition. Give them the definition of keyway. Keyway is a taper groove. It's formed. It's in the concrete. It's used to interlock concrete placements that are made in different times. You never know when they make them keyways. They make them at different times and they make them at different stuff.
That's right. That's right. Go ahead there, co-teacher. All right.
No, you gotta bring back. I got to bring back, man.
Yes, sir. So go to the book. Bible says, study the book and show yourself approved. So it's important that you guys understand the nuances of building. You understand the nuts and the bolts. You're not just going to be a carpenter. You're not going to be just a form setter or a window man or a doorman, a cabinet guy. You're going to know how to build it, how to run a business, because you might want to diversify. Things are getting slow. You want to get out there and you want to be a master framer. This is what this is all about. So we're here to kind of take you along this road. I'm gonna let my fella here talk for a minute and see what he's got to say.
Constructing concrete footing forms. Keyways. Immediately after the concrete has been placed, chamfered pieces of 2x4s called key strips may be pressed into the concrete toward the center of the footing. When the pieces are removed after the concrete has set, a groove called a keyway has been formed in the concrete. See figure 394. A keyway helps to secure the bottom of a foundation wall to the footing. Reinforcing steel. In seismic risk areas, rebar, reinforcing steel, are positioned in footing forms before concrete is placed. Vertical.
All right, what is a seismic risk area? Anybody? Seismic risk. This house is made of brick. This house is made of wood. And this one is made of straw. I'll huff and I'll puff and I'll blow your house down. So if you're down there in Florida, Miami, you got to have houses that are made of brick.
So it's like reinforcement with rebar?
Seismic load is what?
Reinforcement rebar?
Well, that's what you do. That's what you got to do. And you also need to do it down in the brick buildings down there in the Florida Keys and things. But seismic load is earthquakes. So we have earthquakes out here in California. So we make houses made of wood so they can kind of sway a little bit. Now down there in the deep dark jungles of the Pacific Islands, you can have a straw built house because all you got is rain coming down on your head. You ain't got no wind blowing, not necessarily, and you don't have the ground shaking, not necessarily. So you can make a house made of straw. Here you got a house made of wood, and the wood has to be rebar, and you have to have hardware, such as LHA straps and things of that nature to kind of tie the wood together with metal, with screws and nails that ties it together, keep it from pulling apart, so you don't see your drywall popping over. Your stucco cracking because the wood is wet, and when it dries, it shrinks and it twists and it bows. That's why you put plywood shear on the outside. So when this guy throw things at you, I want you to kind of remember what we're talking about, seismic load. California, we build according to the Uniform Building Code, which is the seismic load.
Vertical rebar project out of the footing forms and are later tied to rebar placed in the foundation wall.
Foundation walls.
See figure 395. Concrete is placed after footing form construction is completed, rebar positioned, and provisions made for keyways. Rebar consists of steel rods containing lugs, protrusions, that allow the rebar to interlock with the concrete. Refer to floor plans and elevations when placing vertical rebar in footings so rebar is eliminated at door openings and are appropriate height at window openings. Walls. Form walls are erected after concrete for the footings has hardened and set. Bottom plates are fastened to the fresh, green, concrete as a base for the outside form walls of either job-built or panel forming systems. Except in the case of low-form walls, rebar is usually installed after the outside form walls are set in place. See figure 396. When the rebar has been installed, the inside form walls are constructed. When a large amount of reinforcing steel is required, the steel is typically placed by reinforcing metal workers. Figure 39-3. Stretched building lines. Batterboard stake 2 footing. X. Form. Wall. Footing. Setback distance. Footing form corner stakes. XX. 1. Plumb bob. Nail. Drop plumb bob from building lines. Drive building corner stake and nail.
All right, let me explain this Chinese that he's talking to you all about. Basically, what I just went over, we went through 39.3, which is to stretch the line of the building. This is the outside of your building. That's the actual where the building is actually going to stop and start. So you got a line stretched over here. And then he's talking about our plumb bob, which is basically centering where that wall is going down. That's almost like a basement. Then he has a setback distance, which is where the form is starting, because they want to basically make sure that form is setting straight. Now here, over here in this corner building stake, it shows he's doing something kind of rudimentary. They've got a stake in the middle and he's going both ways. They're kind of putting it in the ground. It's a little different. Footing stakes on the outside. You usually, when you're gonna put a form down there and you got that string down this way, you put that footing stake right up on that string, right up on it. You want to stay straight with that string. You don't want to come out this way in a little bit. You don't want to go out a little bit. You want to stay right up along that string. So when that concrete pours, it's nice and straight. So when you're sighting down the wall and you're sighting down this way, you're sighting straight on down that wall. So you want to create your stakes. Putting foundations in is a very rewarding challenge. you know, and you're making sure that it's square and plumb, you want to also make sure it's level. So you want to make sure that the form is not high over here and low over here. So that concrete slab is like this, you know, or out of square. So you're shooting with a grade, with a laser level, you're shooting the same point, same way when you put in suspended ceilings. You want that suspended ceiling to be perfectly level. So you have 8 feet of suspended ceiling from floor to wall, 8 feet over here. Now, what happens if a guy's foundation is 3 inches? Have you ever come across that, Zach, where you might see a floor that might be 2 inches high on one side and on an inch low on the other? And you got huh?
Oh, we come across everything where the floor's uneven and the room's out of square, everything.
See?
Mainly walls are unsquare.
Yeah, usually walls are so screwy. It's we have to adjust our strings accordingly to the grid.
Right. Now, see, if you'd have been there while they were pouring that concrete, you'd have been standing on his dome saying, "Hey, man, I shot a level on this concrete. It's out of level." You know. Or
I always thought it was the drywaller's fault, but now I know it's the foundation guy's fault.
Foundation guy. If he didn't lay that floor level, then your floor is out of level, and it's because you're using a laser. And your ceiling is going to be perfectly level because you're using a laser and you're going around that room, and it's showing you that it's 69 and a half or 65, 96 and a half or 96 inches. So you're out of level. So when you walk in that room, it looks like your ceiling's out of level, but it's not the ceiling. It's your house. It's your foundation. I remember as a youngster, I worked around. What's that?
It's like if you were to take a measurement, you know, when we do the wall angle on one side and it's, you know, we're having a 7-foot ceiling on this side, and then we go to the other side of the room and the floor is unlevel, and we take a 7-foot measurement, and then we start running our wall angle from that. On my laser, if it's like a huge room, then when we come together to meet, it's going to be off.
Exactly. So what you got to do is you got to establish your 4, 5, and 6, right? And you come off of that, and that gives you, you know, you find the most square corner. And then what's going to happen is that you're going to end up with your towel is going to end up cutting like this, and it looks ugly, crappy.
When you make,
and they're going to blame it on the suspended ceiling guy. So you got to do some cheating. You got to take half of it over here, off here, take a quarter off this end, and a quarter off that end to kind of square it up. You know, so this is looking down at a plan view of the ceiling.
that's the most important.
Right?
Not agree up right.
What's that, Ronald? We got some input. So what you got to do?
Sorry about that, Mr. Mead.
No, that's no problem. What you got to do is you got to make sure that your foundation is right. You know, when you go on that room before they put the drywall and the studs, and then then you get your framer, and he comes in there and he's going to frame the wall, and he's not following force. He's out of square. Might be a slab, and he's over here, and all of a sudden, when you get ready to put your drywall in there, your drywall is kicking this way. So you got so that carpenter is the guy where the buck is stopped. That foundation setting, and then the guys that lay the wall, and I don't know, do you guys are you able to back charge for screwed up stuff? Because it takes you more time now. You got to spend time straightening out stuff and playing with it, when you normally could have just jumped in there and jumped out.
No, they be having people on site, you know what I'm saying?
What's that?
If something wrong, they'll hurry up and abate it. They'll hurry up and fix it. You know what I'm saying? Concrete form, they don't play like that because you're right, because here come wood framer and they the foundation. They laying right after them, and they coming real quick too.
That's right. So that framer, he doesn't want to be having to cut every joist and every sheet of plywood because the damn foundation guy. So sometimes I was on a little old room addition when my sons had a job, and the room addition was like this. So what I had to do is I had to hang that plate out over the slab in order to square it up. You know, I had to come back in there and hang his wall like this. So we came there with that corner. So what had to happen, that carpenter, that concrete guy with this wood hanging over the top, he had to fur it out. Come back and patch and dry patch and fill this in. Because if I'd have followed what he was doing, it was just a little old room addition. If I'd have followed what he was doing, this room addition would have looked like this on the back of the house. And this is kind of looking at it from a down view, y'all. It's called a plan view. So looking straight down from the air, that's what I'd have been looking at. It would have showed this way. No, but I had to, and then so when you parallel that house, looking straight down there from a view like this, one side would have been crooked and the other side would have been straight. So the carpenter has to sometimes straighten things out for the concrete guy, because that concrete guy, fell asleep on the switch. And I've had situations where the slab was out of level and it's just, it's hideous, especially when you're following something that existing and putting something in new.